presentation is one of a series dealing with cargo operations on board an oil tanker. Here we will deal with the basics of pumping cargo. The vessel has reached port and is ready to discharge her cargo of crude oil. To discharge the cargo, the vessel has 3 centrifugal cargo pumps. The pumps are located at the bottom of the pump room. The pump room is situated between the engine room and the cargo tanks. Let's take a closer look at the pump room and how to run the pumps. We will not be looking at the order of cargo discharge, nor will we look at the operation of the crude oil washing system. However, both these are important aspects of cargo discharge. Each cargo pump has a capacity of 4,000 cubic meters an hour. In front of the pump is a mud box with a strainer to protect the pump from solids. There is a riser to the deck line with a non-return valve and a discharge valve. In slow motion, this is what happens. When the pump is running, the so-called impeller is driven at high speed, showering liquid through the pump. The liquid is entering the rotating impeller through the eye in the middle. The impeller vanes force the liquid to the periphery of the pump. Velocity is converted to pressure in the casing of the pump. Let's start with an empty shore tank, an empty line, and a ship's tank filled with 20 meters of fresh water. Let's imagine the pump as a closed valve. Note the different heights marked. In this example, fresh water is shown to simplify the calculations, and we'll be using the metric system. There are manometers at the suction side and the pressure side of the pump. There is also a manometer where the vessel is connected to the shore at the ship's manifold. We are now filling the lines with water. The manometer at the suction side reads 2 kilograms per square centimetre, at the pressure side 6 kilograms per square centimetre, and the manifold manometer 3.5 kilograms per square centimetre. The situation looks like this. There is one column of liquid, 20 meters high, standing on the suction side, called the suction head, and another column, 60 meters high, standing on the pressure side of the pump, called the discharge head. The difference, 40 meters, is the total head. To pump water to the shore tank, the pump must create a head bigger than 40 meters. An additional 3 meters of water is filled into the shore tank. You should note that the pressure at the pressure side of the pump rises by 0.3 kilograms per square centimetre. The pressure has nothing to do with the volume of the pipe or the tank. Only the difference in height counts. There is no change of the suction head. Total head is now 43 meters. This is the static situation. Now let's run the pump. We will use this symbol for the energy added to the system by the pump. The smaller symbols show the resistance in pipes and valves. This is the dynamic situation. Watch the changed readings of the manometers as the pump adds energy to make the water flow. Let's say 5.5 kilograms per square centimetre is added by the pump. In theory, the manometers on the pressure side should show 5.5 kilograms per square centimetre more, but in practice they don't. This is because the resistance results in a pressure drop along the line. Without resistance, the manometer at the manifold would read 3.8 plus 5.5, giving 9.3 kilograms per square centimetre. But the resistance eats 0.2. So the manometer reads 9.1. There is a pressure drop also on the suction side of the pump. So the manometer now reads less than 2 kilograms per square centimetre, 1.8 in this case. Let's go back to the running pump. Now imagine a column of 18 metres of liquid standing on the suction side and a column of 118 metres standing on the pressure side. The difference between the two manometers, 10 kilograms per square centimetre, when converted into a column of water, is 100 metres, so the head is 100 metres. Always calculate the head from the difference between the pressure side and the suction side, but remember, if the suction side manometer shows below 0, you have to add the two readings to get the head. This is the capacity curve of our pumps, the so-called HQ curve. H stands for head and Q for quantity. There are a few capacity curves drawn for different speeds. Here is the curve for 625 revolutions per minute, and here is for full speed, 1,250 revolutions. To find any other speed between these curves, you must interpolate. We use these curves to find the actual capacity of the pumps. This curve gives Q at the speed of 1,000 revolutions. If we run the pump at 1,000 revolutions, we must be somewhere on this curve. In this case, the head is 100 metres. A horizontal line from 100 metres and a vertical line crossing the curve down to the Q scale shows that this pump gives approximately 2,200 cubic metres per hour. If the head is 145 metres and the pump is operating at full speed, we're at its designed maximum capacity, giving 4,000 cubic metres per hour. When you discharge to shore, the situation is not that clear. That is why it is so important to understand the readings of the different manometers. By carefully watching what happens in your own vessel, you will be in control. You know the speed of the pumps, and you know the head. The HQ curves will give you the capacity at any given time. Of course, you should also take ullages every hour to check the discharge. Now we're pumping oil instead of water, but the principle is the same. The specific gravity of the oil is approximately 0.9. Here, the difference between pressure and suction side is 11 kilograms per square centimetre. To find the column of liquid, divide by 0.9 and multiply by 10. So the head is 122 metres. The HQ curves will tell you the quantity being pumped. Before you start a pump, it should be carefully filled with liquid and ventilated. Make sure that all valves between the tank and the pump are open. Check the suction side manometer as well as the manometer on the pressure side. They should show approximately the same reading. This is the time to do a final check on the accuracy of your instruments. Since you know the columns of oil in the tanks, you can calculate the pressures the manometers are likely to show. Check that all valves at the pressure side are open except the discharge valve. To protect against pollution, don't forget to check frequently the integrity of the sea chest valves. A centrifugal pump should always be started against a closed discharge valve. Never forget this. And don't run the pump for more than 30 seconds against a closed discharge valve. Slowly increase the speed of the pump. Watch the manometers. When you have a difference that gives you a head of approximately 60 metres, crack open the discharge valve and speed up the pump a bit. Open the valve gradually and speed the pump in such a way that the pressure is rising, not dropping. Always run the pumps with fully open discharge valves. Try to reach full speed. However, in case of very low back pressure, you may be forced to throttle the flow with the discharge valves so the pumps don't run at overcapacity. If the head is 145 metres, the pump is giving its maximum capacity, 4,000 cubic metres per hour. If the head is more, the pump gives less. If the head is less, the pump gives more. You should not run pumps over their nominal maximum capacity. It is possible to reach the pump's maximum capacity at a lower speed rather than full speed. It depends on the back pressure. Here the head is 113 meters and the speed 1,125 revolutions. You will consume less bunker if you can run the pump at slower speed and still discharge at full rate, so do this whenever possible. When you start the pumps, you should really be on your toes. Have people watch out for leaks in the pump room and on deck. Check the pumps for vibrations, leaks and abnormal sounds. If something should happen, or if you think something is going wrong, don't hesitate to reduce speed or stop the pumps. If you speed up a pump and find you've forgotten to open the tank, stop the pump, then fill the pump with liquid. Then start the pump again. Just opening to the tank will most likely totally wreck a speeding pump. The man at the manifold has reported a flow of cargo. By now the discharge valve is fully open. Now take the pump up to 900 revolutions. Then start the next cargo pump in the same manner. The pressure at the manifold increases as the second pump is taken up to 900 revolutions. Start the third cargo pump in the same manner. You are phasing in the pumps to run in parallel. Take your time doing this. It takes at least half an hour to bring the pumps up to maximum capacity. The pumps are gradually taken up, if possible, to reach their full speed of 1,250 revolutions. Watch the head and increase the speed until the pumps reach maximum capacity, or until the manometer at the manifold shows the agreed maximum allowed pressure. In this case, you have a restriction given by the installation of 10.5 kilograms per square centimetre. All three pumps should run at approximately the same speed and at about the same pressures. With all three pumps running at 1,125 revolutions, the pressure at the manifold reaches the maximum allowed. The pressure side manometers read 12.7 kilograms per square centimetre, and the suction side manometers read 1.7. The difference is 11. So for crude oil with a specific gravity of approximately 0.9, the head is 122 meters. Each pump is giving approximately 3,100 cubic meters per hour. All three pumps give approximately 9,300 cubic meters per hour. This is not full capacity, but you can't do anything about this, as you have to observe the maximum allowed pressure at the manifold. When the pressure at the manifold drops, you can speed up the pumps. You should, of course, try to run the pumps at full speed if possible. If the installation shifts to other tanks, it may result in a different head, forcing you to adjust the speed of the pumps. Your discharge plan should be arranged to share the discharge evenly with the three pumps, to optimize their use. A pump having access to less cargo should be fed additional cargo from other tanks. All the pumps are now running at full speed and the manometers show approximately the same readings. You are pumping bulk. When pumping bulk, your job is to keep the pressure at the manifold as high as possible for as long as possible. Again, run your pumps with fully open discharge valves at highest possible speed. As the levels in the tanks come down, you will encounter other problems. We will talk more about these in Pumping Cargo 2.